like to thank Dr. Lavillette for the kind invitation, and I'm very happy to have joined this very interesting meeting on the impact of climate change in infectious disease. So my presentation will be focused on vector-borne viral infection in Europe. I will talk about West Nile, dengue, chikungunya, and the impact that climate change has in the distribution of these viruses and the increased rate of infection. So you already probably know that several factors are important drivers for the emergence of vector-borne viral infection, like land use, urbanization, travel, trade, social economical factor, the increase in the human population, but also climate change leading to extreme situations like desertification or devastating floods are important driver for the change in the distribution of vectors and hence also the disease they transmit. And this is also happening in Europe. This picture were taken during this season in Italy and represents large areas with floods that occur following a prolonged period with extreme drought and very reduced rainfalls. This also represents risk factors for the occurrence of devastating fires that, together with the increase in temperatures and the arrival of alien animal species like birds, mosquito, are increasing the risk for the occurrence of viral infection, arbovirus, that are typically considered to be exotic. This is the case of dengue, Zika, chikungunya, maybe also yellow fever, which are transmitted by, as you know, Aedes aegypti, which is widely distributed all over the world in the tropical area. But also the Asian tiger mosquito, Aedes albopictus, is a competent vector for these viruses. So areas, and is present in the southern Europe, also in Korea. So these areas are at risk for the occurrence of outbreaks. These invasive Aedes mosquito are expanding their geographical range in Europe. These data are updated as of October 2023. And here there is the map showing the current distribution of the tiger mosquito, Aedes albopictus, which is moving in northern area. It has been already introduced in the Netherlands, even in Sweden, even if it has not established yet there. Aedes aegypti is also still present in Europe. In the past, it was widely distributed in several countries. Then it was eradicated, but the environment is suitable for the incursion of Aedes aegypti. It has already established in Cyprus. It arrived also in the Netherlands, even if not yet established. And both of these vectors are competent for the transmission of dengue, chikungunya, Zika, many other viruses, some of which have been demonstrated to be efficiently transmitted by vector competent studies in the lab. Aedes japonicus is present in the central part of Europe, and it has been shown to be able to transmit West Nile virus. Aedes coraicus is present in some countries in the northern part of Italy and is rapidly expanding. It is not considered to be a relevant vectors for arboviruses. It can transmit Japanese encephalitis virus in some parts of Russia, but now we are conducting competent studies in the lab to evaluate if maybe it could be transmit West Nile virus or other vector-borne viruses. So given this situation with the spread of invasive Aedes mosquito, European countries are vulnerable to the introduction of viruses like chikungunya, dengue, and Zika, and the occurrence of local transmission. And this has actually happened in the past with several outbreaks, with a few cases or even a larger number of cases of infection locally transmitted in France, in Spain, in Italy, Croatia, also a huge outbreak of dengue in Madeira, this island from Portugal. However, in this area there is Aedes aegypti. This posed the risk, of course, for the population because of the disease, but also for the safety of substances of human origin. So when autochthonous case occur, we need immediately to start screening all the blood donors and also the organ donors in order to prevent human-to-human transmission. Europe first realized to be vulnerable to this infection in 2007 when, for the first time, a huge outbreak of chikungunya occurred in Europe, so in an area not in the tropical area where we typically found this virus. It occurred in the northern Italy. And it followed the introduction from a man returning from India. He was viremic. He returned in a small village that was near a river, Castiglione di Cervia, separated by a river from Castiglione di Romagna, few inhabitants in a rural setting. This is a picture taken at the time. There is the river, a lot of vegetation. So the ideal environment for the tiger mosquito spread. And this was the starting point for a quite huge outbreak. This is the epidemic curve with over 300 cases of infection. Since then, Italy announced its surveillance system to prevent infection from exogenous, so imported infection, and also from autochthonous cases. And indeed it worked because the following year we detected the first human cases of West Nile virus, which however was autochthonous. And in the following years, we didn't have in Italy other autochthonous outbreaks, but after 10 years, in 2017, there was again a huge outbreak with a total of 500 notified cases of chikungunya in the area of Rome, and then another cluster in the southern part of Italy, all originating from a single introduction, probably from Pakistan, as demonstrated by phylogenetic analysis of the virus responsible for this outbreak. But probably this represented just the tip of the iceberg, because probably the cases were much more numerous, so many more cases. And there was also one case of death due to this outbreak. The virus was isolated from both outbreaks, and it was demonstrated that it could be efficiently transmitted by the local population of a tiger mosquito, even if the virus, the isolate of the second outbreak, didn't carry the mutation in the envelope protein that has been associated with increased fitness in the tiger mosquito. So the local mosquito can transmit the virus, and it was also confirmed by this study conducted by the German colleagues who collected mosquito from South Italy and southern part of Germany, and they tested the ability of this mosquito to transmit chikungunya at a different temperature. They showed that the virus can be very efficiently, the highest transmission efficiency occur at a relatively low temperature, 18 degrees. So temperature actually is not a limited factor for the transmission of chikungunya in Europe, and maybe the only factor is really a vector distribution. Indeed, high temperature higher than 18 degrees for quite a long period of time occur quite commonly in several countries in Europe, and actually in all the areas where the tiger mosquito is present. So in country where this mosquito is established, it is very important to implement a surveillance system for human cases, of course, also entomological surveillance, and the implementation also of suitable control measure in order to prevent outbreaks. We recorded the first outbreak of dengue in Italy in August 2020. This is the environmental setting, so a village in the northeastern part of Italy where there is established Aedes albopictus mosquito, but there is also Aedes corecus, Aedes japonicus, so a lot of mosquitoes here in the rural setting, fortunately, low density of population. According to the surveillance plan in Italy, when a case of dengue, chikungunya, or Zika is identified, either imported from a traveler or autochthonous, the patient is recommended to remain at home to avoid biting from mosquito, and immediately there is a control of the vectors with disinfestation in a buffer area of 200 meters around the house of the patient. And this was the case. So this patient infected the household contacts, but after a few days there were cases identified also in the nearby areas, so another disinfestation was conducted. We had the opportunity to monitor this case. I would like to remind you that at the period in August 2020, we were again in the COVID time with restriction in travels. And this was a lucky situation because it avoided the expansion of the outbreak. So at the end, we had only a total of 11 cases of local transmission. We could monitor all these patients with replete blood and urine sampling. We demonstrated that urine was very useful to confirm cases even at a long time after the onset of symptoms. And anyway, the last case of infection occurred in late summer, so it was in October, it was already autumn, and so we should remind that also the period for transmission is becoming longer and longer in European countries. Now the situation is a little bit more worrisome in Europe. There is also this commentary in Nature that reporting that the dengue is spreading in Europe, and this is probably the consequence of a travel boom after the COVID period, combined with a very warm summer, a very long summer period that increased the risk of local outbreaks of dengue and chikungunya. So far, in this year, 81 cases of local transmission of dengue have occurred in Italy. Many cases also reported in France and some cases also in Spain. And this is occurring in the context of a global rise in the number of dengue cases. 4.5 million cases reported so far from over 80 countries globally, and over 4,000 dengue-related deaths. And now European countries are counted in the global map among the countries reporting dengue transmission. This epidemic curve in the lower graph reports the number of human cases of dengue that have been reported in Italy since 2015 to 2023. So the dark green color represents the imported cases, while the pale green color represents the autochthonous case. I would like to show you that the local outbreak that occurred in 2020 in our region was in the context of a very small number of imported cases because of the restriction of the travel during the COVID period, but we should always be very careful. The index case was testing only for COVID. It tested negative. Anyway, according to the rules, it was recommended to remain at home in quarantine for a couple of weeks, and this was also the opportunity to transmit the virus to the household contacts. Anyhow, according to the protocol, this patient should have been tested also for the arboviruses, and this was not overlooked at the time. So we should always be very careful about this. And this is the current situation. We have a lot of imported cases, so there is an increased risk of local transmission and introduction and local transmission of these viruses. And we should expect in the near future a further rise in the number of cases because of the global warming, especially in the northern areas in Europe. And these are some map with some modeling studies showing, it is more clear from these images, that temperate region like Europe, the Western Pacific area will become at an increased risk, so more suitable for dengue transmission in the next years, especially in the rural areas, and the population at risk globally for dengue will dramatically rise in the next years. A few words about West Nile virus. The transmission cycle for West Nile is a bit more complex because humans are dead-end hosts. They can be infected by the virus by the bite of the mosquito. They can transmit the virus through blood donation, organ donation, but not directly from human to human through the mosquito bite, while the reservoir is represented by different wild bird species. The most important vector is represented by Culex pipiens mosquito, which are widely distributed in several European countries, including northern countries. And this map represents the cumulative number of West Nile human cases of West Nile virus infection that have been reported in European countries. Most cases are reported from southern countries like Italy and Greece, but also from Central European countries, so Romania, Hungary, but also Germany, the Netherlands. So the virus is now moving to northern areas. This is the current situation from this year. Again, a lot of West Nile cases, and the introduction of the virus also in new areas, like in this area in France, in Spain, where in the previous years no cases were reported. So the virus is still expanding. Within a research project, a consortium, we investigated, based on the full genome sequence of West Nile virus, the dynamics of the spread of the virus among European countries. So it is a phylogeographic and time clock analysis that allow to identify two main routes of spread of the virus in central and northern countries in Europe and in the Balkan area and Greece. Anyway, this analysis allowed also to identify which were the environmental driver of West Nile virus dispersal, so mainly in area with high farming density, with high urbanization, with high coverage of wetlands, and the presence of bird flyways. And we also analyzed the impact of climate factors in the diversity of the viral genome. So high temperature, also the low wind and low precipitation represented important drivers that probably accelerated the dispersal of the virus, its replication, transmission through mosquitoes, and hence the accumulation of mutation. There are also experimental studies at a different temperature that demonstrated that the temperature has an effect and condition the type of mutation which are accumulated in the virus, so a driver for mutation. And all these factors are present in our region, in the northeastern part of Italy, which is considered a hotspot for West Nile. We every year record a lot of cases, human cases, with peaks in 2018. We had hundreds of cases of infection, and also in 2022. I reported in this graph some temperature and rainfall data. These are average data in the year base. And you can see there are several fluctuations in these values. The dotted line represents the average density of mosquitoes with a lot of fluctuation. In the middle graph, it is reported the number of positive mosquito pools for West Nile, orange and red for the two lineages, lineage 1 and lineage 2, and Usutu virus, which is also included in the surveillance plan in Italy because it has the same transmission cycle, even if it is less pathogenic than West Nile. And we observed some correlation between the number of positive mosquito pools and the number of human cases that we reported, even if there is no linearity, probably. And anyhow, the combination of factors associated with the occurrence of huge outbreak varies in different years. For example, during the last year, the number of mosquito, so the average number of mosquito was really very low. Probably the lowest ever recorded, but the number of infected mosquito was very high. The rainfall, so the precipitation was really very, very low. High temperature, both the minimum and the very record high temperature. And there were a lot of human cases, but there was also red color, the introduction of a new strain of West Nile virus. So in the previous years, there was the endemic lineage 2 West Nile strain, which is quite widespread all over Europe. But last year, we recorded the incursion, the arrival of a new strain of lineage 1, different from the one that were circulating in the previous year. And analysis in the mosquito population, which is surveilled under surveillance, and in wild bird population, we observed that while both viruses strains were equally circulating in the mosquito population, most of the wild birds which were collected by the recovery center as dead birds carried the West Nile virus lineage 1, so the new strain infection, with a trend toward a rapid increase in the infection rate. These are the data of the final analysis that I want to sum up with a few words. So in symptomatic equids, wild birds, those that are dead, and humans with mainly detected West Nile virus lineage 1 and less frequently lineage 2, while in the blood donors and in the mosquito population, which can consider like the denominator of the circulation of the virus in the region, we detected equally the two strains. And we analyzed the human cases according to the presence of symptoms, and we observed a statistically significant association between the presence of this new strain, lineage 1, and the occurrence of the neuroinvasive disease. And now we are conducted in studies in organoids and the animal model in order to detect if there is any genotype phenotype correlate of this epidemiological observation. And this is some concluding remark about this topic. So what we are observing globally, but also locally in Europe, in my country, in Italy, is that together with the global, with an increase in the temperature, there is an increase vectorial capacity of mosquito, and including the invasive Aedes albopictus, and this may expose climate. Temperate region to the incursion of new vectors and hence the vector-borne pathogens and these exotic viruses, and but also the re-emergence of endemic vector-borne disease like West Nile virus, which is spreading in other areas that are not considered typically at risk. And this climate change, so the increase in the temperature and the reduced rainfalls are also driving the genetic evolution of the virus, and resulting maybe also in a novel genotype that can be associated with increased pathogenicity. And I want to thank you all for your attention and acknowledge funding from the University of Padua, Veneto region, and the EU.
Thank
So
you.
thank you for your attention.
Thank you, Professor Barzon. Thank you for presenting really in-depth study, climate changing related to 3 important viral infection in Europe. So I believe it's very early morning for you. I think that we could have one question before we let her leave. So any questions on the floor? Yes, go ahead.
Thank you very much for your very nice presentation, very interesting. I have a question concerning, of course, Europe and regarding the different outbreaks you mentioned in terms of chikungunya, dengue, and Aedes albopictus. It seems that even the mosquitoes is installed in the cities, in the big cities. Most of these outbreaks are in the rural environment. Agree? And how you explain this?
It actually the tiger mosquito is has a behavior that is a little bit different from Aedes aegypti. So it is established more abundant in the rural setting at variance with the Aedes aegypti. So the starting point generally is in the peri-urban setting and in the rural setting where there is a lot of vegetation, less disinfestation, and the presence of a breeding size for this mosquito. But like in the case of chikungunya outbreak in 2017, also Rome, so the city of Rome was heavily affected by the outbreak. So also the urban setting, also the big city, are vulnerable to this outbreak and mainly chikungunya. And now that the outbreak of dengue is occurring in Rome, so in the city, not just in the rural setting.
Okay, so it's meant for the the prevision is not very good for the Olympic Games in Paris next year.
Of course, but we should be very careful and take all the countermeasure to reduce the abundance of mosquito and all this, disinfestation activity in order to mitigate the risk.
Thank you, Professor Barzon, for your great presentation. Thank you. So we, this second session, we have all 4 speakers, and then I believe that we heard and know a lot of the data, which is related relationship between the climate change and the infectious disease. I think this is the very good starting point that we can make the preparedness for evidence-based ones. So thank you for everyone for participating in the session.